also untick the checkbox for active full, well then this is where we start utilizing the first backup mode that we call forever forward increments. But let's take a look at each of these and see how they work. So the first one is reverse incremental, and at the top we have source blocks. So keep in mind, source blocks indicate backup files that are running from some production host that I'm trying to protect. So every time you create a new job, and this new job runs the very first time, well, you can probably guess that we need to perform a full backup, right? So we have everything from that one virtual machine. So the first time this is running, and in this example, that's a Sunday, we get a .vbk file on the repository. The next day this is going to run. What's going to happen is, notice here that we essentially will take the VBK file and move that up, so this is now Monday's restart point. And in this file we have the A block. But you can see at the top in production that on Monday, between Sunday and Monday, A has been modified in production. So what we'll do is what's also called a copy on write. So we'll take that A block and move it out of the VBK file to a new .vrb file. And at the same time, we'll replace it with the A1 block from production. And as we continue moving each day, well, on this day here, currently there's a new C block. So we'll replace C with C1 and copy the C block out to the Monday's VRB file. This continues as we keep moving forward. Now, if you remember correctly on the screenshot, it said that this was slower. Well, as you can imagine here, there's a lot of random reads and writes because we need to do all of this processing. This is also part of why reverse incremental is slower. What about retention? Well, in this example, we've configured the backup job to reverse incremental, and I've configured it to have 4 restart points. This is also what we call the retention policy. So how far back in time do we want to go? Essentially, once the specified number is exceeded, the earliest restart point will be removed automatically. So let's take a look here. So Monday, we have 2. Tuesday, we have 3. Oh, and now suddenly it's Thursday. We have 1 too many. So we have 1, 2, 3, 4, 5 restart points. Now, because this is essentially dependent from Thursday and backwards in time, as opposed to some other vendors where the full backup file is the oldest file and then forward incremental. This means that the Sunday file is not having any other files depend on it, right? So I can just go ahead and say, well, in these Monday to Thursday, I have my 4 restart points. You can just delete the Sunday restart points, and no one else will suffer from this. And then, of course, this continues each day as we start moving forward. Forward incremental. Now, don't get confused by the example. So in the example here, yes, question?
Can you repeat that?
Which part would you like me to repeat?
Like why that Monday backup, Sunday backup, A to do that.
Well, because we have the full backup. So this is the newest thing that we have there. So this is what you can see on the screen right now.
If I have to refill the VM, I will refill it from Thursday, or I have to combine from Monday to Wednesday.
Well, which state do you want to restore the machine? Which state do you want to restore it into? Do you want to restore it into the state it was when you created the backup on Thursday, or Wednesday, or Tuesday, or Monday?
No, later. If I want it to be restored to what it was created, like from Thursday, so I will go to Monday.
So in that case, you go into the restore wizard and you select restore point Thursday, and then we just read whatever blocks we have in this VPK file from Thursday. You don't need to read any of the other files because they only have data that is older than Thursday.
Okay. So the Thursday would be a full backup.
Yes. So every time we run the job, the newest backup is always a full backup.
If I want to return the parent on Tuesday, then
So then we will use the metadata to determine exactly which blocks do we need, and then we'll take, in this case, and restore A2, B, let's see here, sorry, no, you said Tuesday, was it?
Yeah.
Yeah, okay, so then we'll use the metadata and we'll see, okay, we just need to restore A1, and we need to restore the D block, and we need to restore the B and the C1 block. So then we just create pointers to blocks that we need.
so it would be on Thursday. It would be on Thursday, and the A1 would be determined from metadata.
So is
It
it,
will not equal the
so don't be confused by how other products work. So some products, they will take one file, restore all of the blocks, then take the next file, restore that on top of it, and then the next file on top of it. It doesn't work like this because this is a waste of time and resources. So when you tell us you want to restore back to a certain date, we will use the metadata to see exactly which blocks you need to go back to this date, and then only restore the blocks that is needed to achieve exactly this date. Right, so in this case, we need to read some blocks from the Thursday file, and we need to restore some blocks from the Tuesday file.
if I'm asking the Tuesday, it will only be the A1 block. That is it.
The A block, well, the A block is from Sunday, and on Tuesday, that block was replaced by A1.
A1. No, I'm saying if I want this to equal 5 from Tuesday, it will only equal A1.
Well, no, because A1 is, these are blocks of data. These don't represent files inside a virtual machine. These are blocks of data. So we can't identify one file inside a virtual machine based on this. So if you want to restore one file, we'll have to open up the DDKs. If you're looking to restore the entire VM, then you need to read all of the blocks. Then based on which day you want to restore back to, we'll determine this. But all of this is happening completely on the background. If you want to try and see how it's being mounted on the host, I suggest that when you get to the lab, you can try and restore a machine. We're doing that tomorrow. And then just take a look inside the vSphere logs or the event and task log, and you can see exactly what's happening there. But from the administrator point of view, one second. From the administrator point of view, you just need to tell us which restore point you want to go back. All of this is handled automatically in the backend. Was there a different question?
No, it's absolutely the same one. In the same example, we do have full backup available for Thursday, right?
I'm sorry, I didn't understand what you said. Could you repeat that a little bit slower for me?
Sure. In the same example, we do have full backup available for Thursday. Okay. I want the system to be restored as it was there on Tuesday. So what are the things I need to restore for that?
Well, you just go in and select the restore point for Tuesday, and then we will only select the blocks that's needed for this restore. You don't need to do this on the back end yourself as an administrator. You just need to figure out which day you want to restore back to. Right, so the important piece of information here is, will we restore all of the data for every day? No. Will we restore only exactly the box that we need based on the restore point you selected? Yes. So just enough data is going to be restored. No overhead restores at all.
So, what if there is something happen and we need to restore all of the data? So, we won't be able to restore all the data then because you have created the restore point that you are telling on Tuesday, Wednesday. So, what in case you want to restore all of the data if something happens?
Well, as long as you have the restore point, right? So this example here on the screen, right? So then we have the 4 restore points plus Sunday. Right? So we just deleted the Sunday restore points. Since you told us you only wanted 4 restore points, of course you cannot go back to the way the machine was on Sunday. But you can do a complete restore the way the machine was on Monday. You can do a complete restore the way the machine was on Tuesday. You can do a complete restore the way the machine was on Wednesday. And you can also do a full restore the way the machine was on Thursday.
So all the blocks will be restored, right? If I am doing, for example, on Monday I am doing the restore for Sunday. So all the blocks will be restored for Sunday, correct?
So if you're on Monday and you say you want to select Sunday, then yes, the blocks that the machine had on disk when you performed the backup on Sunday, those are the same blocks that will be restored back.
Okay, so not all the blocks, only which I have selected, right? Correct?
When you say the ones that have seen an update, what will be, I don't know what you mean, but what I can tell you is that the state the machine was in on Sunday, so if I go back in navigation, this is the state. Blocks A, block B, block C, block D. Those are exactly the blocks that will be restored. So for example, here, once we go to Wednesday, now we suddenly have some new blocks. So A1, this is not going to be restored. C1, this is not going to be restored. A1 is not going to be restored. Because that's not the state the machine was in on Sunday. On Sunday, it was block A, block B, block C, block D. Those are still on disk. And those are the only blocks that we will need to restore.
Okay, so what about the new block? It will be restored next week, right?
Well, that depends. If you start a new restore next week, then whatever blocks are in the restore point that you select, those are the blocks that will be restored.
Oh, okay, I got it. So only blocks which I have selected that will be restored. I got it. I'm clear now. Thank you.
Great.
So basically, it will not restore everything.
I'm sorry, I lost you. I can't hear you anymore.
I'm telling you that it will restore only the blocks which I have selected before. That is not restored, correct?
Okay, so let me ask you. You selected a restore point from Sunday. Let's use this example.
Okay.
Which blocks was on disk on Sunday?
For example, C.
Well, in the example that we have here, I'll go back to you. So this is Sunday now.
Okay.
Which blocks do we have on disk
Okay.
on Sunday? In the production environment.
Looks like A, right?
Well, and
A and D.
and C and
Okay. A, B, and
D.
C. Okay.
So there are 4 different blocks contained inside this backup.
Yeah.
So if you select
Okay.
the restore point from Sunday, and this restore point is still on disk, then what will be restored is going to be A, B, C, and D. If you select
Okay, that was my point.
if you select the restore point,
Okay, I got it.
so what did we have on disk on Monday? That was A1, B, C, and D. So if you selected Monday, those are the blocks that will be restored back. If you select Tuesday,
I got it.
it will be A1, B, C1, and D. Because in the production environment, these were the blocks that were there when we started the backup.
Okay. Okay. It's clear now. Thank you.
Great. Any other questions? Okay.
Not incremental backup. The synthetic backup will be enabled by default, and you will see the data block unchanged is getting appended to the next page. The synthetic backup affects background for them.
I'm not sure if there was multiple questions there. It sounded like the question was which backup mode is the default backup mode? Was that your question?
No, for reverse incremental backup,
Yes.
as you in the stage that is setting for each page there is some kind of changes. So for the same data block, it's added to that specific along with that unchanged data appended to the backup. It's like a synthetic tool, right? Is it something which should be enabled by default, or we need to label or revolving system.
Okay, so the question was actually about the default backups. So if you select reverse incremental, this is exactly how it works. You don't need to do anything extra. But it's not the default backup mode. I will leave it for you when you get into the lab environment to investigate what actually is the default mode. And then when we get to the end of the lab, so we'll forward and we'll discuss what your findings were.
Really?
Okay, now in the example here on forward incremental, please don't get confused. At the top we have disk and at the bottom we have tape. That's not because if you want to use forward incremental that you then must use tape. It's just an example, right? So yeah, if you only want to use disk, you can still use forward incremental. That's completely fine. We just sort of took two examples and combined them into one, I guess. Okay, so at the top, again, we have the production environment with the source box. When we run this the first time, we have the full BPK file on disk. So this is a backup job. If I didn't have a backup tape job running afterwards, then we could simply just copy these blocks down to tape, it's BPK. The next day, we can see, oh, A was changed to A1. So when you run forward incremental, we essentially just back up whatever was changed. So we get this zip file on disk one day. If we want to use tape, we can just copy that one zip file down to the tape. And this essentially continues as we move on each day. We just get one zip file. This also means that it's very easy on the storage because we're just doing sequential writes. Retention for incremental backups. So keep in mind that we have two different types of forward incrementals. We have forever forwards, and then we have regular incrementals. Now, for the regular incremental, we actually need to build up a chain. So let's say that you said, hey, I want to have X amount of restore points on disk. Well, then these need to be reached before we start deleting the old ones. In the example over here, with forever forward, well, then you always get the amount of restore points that you selected. So if you told us, hey, I only want to have, say, 1, 2, 3, 4, 5, 6. So let's say I said I want to have only 5 restore points. Well, then once number 6 is written down to disk over here on Friday, the oldest bit file, all of the contents in here, will get injected into the DMK file and overwrites any existing blocks that are sort of older versions of what's in here, and any new blocks that didn't exist already will just be added. So this BPK file is probably going to grow and grow and grow and grow and grow over time. This also means some additional load on the storage, but the good news is you only need to have one full backup on disk. Over here you can see that I said I want to have 3 restore points. So I actually have the full, and then 3 incrementals, so that's already 4. But because I can't start deleting incrementals, oops. So then I need to create a new full. Because for a forward incremental, you have to create some periodical full backups. Those could be synthetic fulls or active full backups. So in this case, I create a new full, and 1, 2 incrementals. Now I have my 3 restore points, which means I can just start deleting the old backup chain. But let's try and take some examples. Hopefully it makes sense. So the first example is for forever forward incremental. As always, we start off with the full backup. The next few days we're creating incrementals. You can see here we actually now have 4 restore points. But in the example here, we configured the job to only have 3 restore points. So that means that the number of restore points is exceeding retention policy settings. If the number is exceeded, then the backup application will transform the backup chain to make room for the most recent restore points. And as a result, you will have the exact number of restore points indicated. So this contents of the Friday bit file will get injected into BPK. This work. You can see the A1 block completely overwrote A block. This continues each day. if we take a look at a normal forward incrementals, not forever forward, then it's slightly different. So let's say here we set again 3 restart points I have to full, 1, 2 incrementals. So actually I have the 3 that I want now on disk. Then the job continues, doing some incrementals, and then perhaps once we reach Monday, we set up the job to say every Monday I want to have a new full on disk. But the problem is now I've actually exceeded my retention policy. But there really isn't anything I can do about it right now. Which means right now I have 1, 2, 3, 4, 5 restart points. Even though my job retention policy is only 3 restart points. So we actually have to get all the way, not to Tuesday, but even to Wednesday to say, now I have a backup chain. With the VBK, 2 bits. So there I have my 3 restart points. Once I've gotten those on disk, then I can go backwards and delete the old files. Which of course is happening completely automatically in the background. So the key takeaway here is, when you set up your retention policy and you're using forever forward incremental, the number you specify is also the number you have on disk. But if you use forward incremental, then the number of restart points you specify is going to be the minimum amount of restart points you specify. Now in the example here, we use some very small numbers. I've seen some customers do some crazy things because they didn't completely understand how this works. So for example, I had one customer who said, oh, I want to have 7 restart points. Okay, well that's great. But then in the job, he also set it up to say, well, I actually only want to do an active full every 3 months. So now you can imagine that we need to have a full, and then incrementals every day, 3 months. And then after the 3 months, we'll do a new active full. And then we need to get 6 more restart points. And then those 90 or so old restart points can then be deleted. So suddenly this can lead to unexpected high disk usage on the restart point, because the customer didn't completely understand what the settings they have selected would mean. Now, I'll give you a brief example here. I have this website, and let's see here. So I just posted a link in the chat. Show you a quick demo of how this tool works. So this is the restart point simulator. Now let's say here at the top that I said, oh, I want to have a monthly active full. And I said I want to have only 7 restart points. And I said, okay, well actually only want to have this every 3rd month. January, March, July, October, and back in January again. So if we can simulate here, so what's going to happen, you can see I'll actually get as many as 97 restart points on disk, right? Because I need to get to full, and we have all of these incrementals here that are going to be running. And then finally I get another full, and then we get these additional incrementals down here. But this is also a great sizing tool, just to get ideas. Put it up here, how much space are you using in production, how many restart points, what's the change rate, and so on. And actually, this will be very useful for getting some sort of idea on how much storage you actually need. So in this case here, with the settings, it's 1 terabyte use and the restart points. See, well, then you should size this as approximately 1,325 gigabytes on disk. I put the link in the chat for you, so you can have a play with this after the training if you want.
For example, we have a backup, which is 5.7.
Yes.
After some time, we found out that we started to let the customer to change the restart point. Something that won't change it right away, or the community just to that, or not,
Yeah, great question. So actually what you would do is just edit the job and change the number from whatever it is to the new value that you want. Just notice here that if you are lowering the amount of resource points, then you need to run the job again. So let's say the job is scheduled to run this evening. You change the number from 3 restore points to 2 restore points, for example. Well, then when the job runs next time, maybe this evening or something like that, then any excessive restore points will just be deleted. The oldest ones or burst in, depending on what kind of settings you have. As I mentioned, we have a few additional options here. One is active full. And this is a way for you to go ahead and say, hey, here is the time we reach this day. So it could be, for example, once or more per week, or it could be a month, or essentially whatever schedule you would like. We will connect down to the production storage and form a complete full backup again. Now, as you can probably imagine, this puts quite a lot of load onto the production environment because we have to read all of the data out again. And then we need to store it down to the backup storage. But because we're reading everything out sequentially, yes, we'll use a lot of storage, of course, full size of the full backup, but it's pretty easy on the storage in the way that all of the writes will be sequential. If you use synthetic full, actually what happens is we'll connect down to production storage, just perform one incremental to get the newest data, and then we'll create a new synthetic full backup on disk, meaning we'll take all of the blocks, all files, but only the newest blocks, using what we already have on the backup storage, and then create this new full backup. Let me show you what it looks like with the animations. So here first we have the full backup. So whenever this runs, of course, we start with full backup. Then we have the incrementals that are running. And then on this case on Thursday, we pull out everything again as the state of the production system on Thursday. And now we actually have 2 fulls on this. If you take a look at synthetic full, well, as always, we start the job off with a complete full. Then we have the incrementals on each day. Then on Thursday, you can see we started out with a incremental, but we didn't actually take all of the blocks from production. We just looked at, okay, what are the blocks in production? The blocks that we already have on disk, we'll just copy them over. And then the newest blocks since Wednesday, that was the incremental that we pulled out first. In this case, I think it was A2, that was the first block. So this is very light on the production storage, but of course, as you can probably imagine, very heavy on the repository storage. If you use synthetic full backups, there is actually one additional tick box here called transformation that allows you to transform the incremental backup chains. So as we learned previously, if you select incremental with synthetic fulls, well, then you'll have multiple fulls on the disk. From time to time, some customers say, well, I want to use incremental with synthetic fulls, but I don't want to have multiple fulls on the disk. Well, then you can use this tick box, and we'll make sure that you only have one full on disk. The trade-off is, though, that we use a lot of performance on the disk system to be able to achieve this. The trade-off is that you get just the one full backup on disk. So what does that look like? As always, we start off with the full. Then we have incrementals. We get to Thursday. Now we probably want to run this transformation. So normally we would start rebuilding this synthetic full on Thursday. But that's not what's going to happen. Keep a close eye on the file names. Right now you can see Sunday is a DBK file, Monday is a BIP file. Now I'll start this transformation process. Actually, similar to what we did with the reverse incremental, this is moving forward every day. And then finally, it's processed all of the files, and you can see Sunday, Monday, Tuesday, and Wednesday have now become VRP files. So right now, this looks like a reverse incremental backup job, but it's actually not. Now, when we get to Friday, we just perform incremental again, and this is of course still a web file. And so when we hit Thursday, because you enabled synthetic full and you enabled transformation, you transformed all of these files. Does this make sense? Okay, so what is the impact for each of these? Well, active full is just one write IO, sequential writes. Forever forward incremental, that's three IOs. First, we perform a write to write the bit file down. Then we perform a read to read the oldest bit file. Then we perform the second write to inject the oldest bit file into the BBK file. Forward incremental, also just one sequential write. Reverse incremental, well, that was one write to write the newest block into the BBK file. And then at the same time, we use this copy and write, so we read the old block that we are replacing, and then we do the second write to write a new BRB file on disk with the reverse incremental. Synthetic full, well, this was two IOs. One read IO for reading old block, and then one write IO to inject this old block, current block, you can say that we already have on disk, into this new BBK file that we're building. Finally, synthetic full, transform to rollbacks. Actually, we have 4 IOs because we're also doing process transformation. So really, I would not suggest anyone to use synthetic full with transform to rollbacks. But yeah, it's an option that I wouldn't really recommend. If we try and do a comparison between these 3 backup modes, forever forward, forward, and reverse, well, the speed of the backup, well, forever forward is definitely faster than reverse, but it's slower than forward. What's the reason for that? Well, actually, that's because forward is just dumping new files down, then it's finished. With forever forward, we have to write the same bit file, but then we also need to handle the merge. With reverse incremental, well, it's slower because all of this transformation is happening while the backup is running. That slows down the whole performance. Common question is, what about the restore speed? I've seen people on forums and so on say, hey, if I'm doing a restore from a BBK file, that's going to be faster than excuse me, than if I'm restoring from, for example, a BBK plus 10-bit files. Well, actually, that's not the case because this is not how Veeam works. When you select the restore point, you use the metadata, as I explained earlier, to determine exactly which blocks is it that you need. And then we open up multiple read threads to write exactly the blocks that you need down to the production storage to bring it back. So the restore speed is going to be the same regardless of which of these modes that you selected. Ability to restore to the latest state of a virtual machine in case one or more backup files in the chain are corrupted. Okay, so with forever forward, we have just one full and then many incrementals. So if one of those incrementals are broken, well, then I will only be able to restore to the restore point just prior to the one that's broken. The same thing happens with forward incremental because they work exactly the same way. However, with reverse incremental, well, it depends on which file is broken. If it's the newest one, you can still do it. If it's an older one, well, then you'll be able to restore until the day after the broken one. So the point I want to try and make here is that sometimes people ask me, well, why should I ever use reverse incremental? It seems like it makes no sense to use this one. Well, in general, as you saw with the 3-2-1 rule, we recommend that you have a backup and then a backup copy. Now, some customers don't want to make a backup copy or they don't have the budget to have multiple storage systems. If that's the case, they might decide to have a lot of restore points. One backup drops, they still have potential time-wise. So if someone says, hey, I want to have 100 or 150 restore points, then I would strongly suggest them that they use reverse incremental instead of forever forwards or forward, because in case something is broken in the block, at least they will be able to get to the newest backup instead of having to go perhaps 100 days back in time. That is maybe not the most ideal situation. The next item is the capability of the storage, of the amount of restore points in storage. So forever forwards, it will always be exactly the amount that you state. Reverse incremental, always the amount that you state. And forward incremental, it says here, often more than you state in the job settings. I think I'll dare to say that it's always going to be more than you state in the job settings. That's sort of the nature of how it works. But of course, there will be a few days, namely the day that it reaches the new backup change retention, where, yes, okay, on that one day it will be exactly what you need, but all the other days. Then we have compatibility with slow backup storages. Forever forward, not that good. That's because of this merging process, so it's some slow storage system. Especially sometimes customers like to buy some very cheap NAS from one of the cheaper vendors because of budget constraints, for example. Yeah, then maybe this is not really the best way to do it, or at least you need to align your expectations with there will be some processing. This processing is going to take some time. Forward incremental, it's very good because we just do writes now and that's it. So there's no way to optimize that any further. And reverse incremental, well, that's probably going to be really slow because all of these random reads and writes, typically these cheaper storage boxes don't like that very much. Compatibility with tape. So both the forward incremental ones can easily accommodate that. Reverse incremental, well, it's just limited. Why is that limited? Try and think of it this way. Every day, your newest restore point is a full backup. If I run it backup to tape job afterwards, well, what is it doing? It's copying the file down. So that means on my tape every single day, I'll be getting a full backup. Now, for some customers, that's exactly what they want, and in that case, it's great. It's a good choice. But for most customers, they don't really want to have a full backup on tape every single day, because that could be quite expensive tapes. Finally, compatibility with deduplication appliances. Further, forward incremental, no. Reverse incremental, no. Forward incremental, yes. So why do we have no on these two? Well, because the way deduplication appliances work is that the utility write data down, and then Box is deduplicating this data. But if I come along the next day and I'm touching all of this data, I need to read and write it. That typically means this data needs to be rehydrated. And if I'm rehydrating the data every single day, then the deduplication rate is going to be very low, plus the performance is going to be really low. So if you're actually storing your backups on a deduplication appliance, then you really should be using forward incremental. Change block tracking. So how this works, it depends a little bit on which hypervisor you're using. If you're using vSphere, a recent version, which means you're using virtual hardware version 7 or newer, so this is like really old, then VMware has native change block tracking, CBT. So you can just leverage that. For Hyper-V, it depends a little bit on which Hyper-V version you're using. So Hyper-V introduced something called RCT, or Resilient Change Tracking. This is essentially exactly the same as how change block tracking works in VMware. There are some small differences on the actual implementation, but functionality-wise, it's pretty much the same. So if you're using Hyper-V 2016, and your VM version is equal to or higher than 9, cluster level is equal to 8 or higher, well, then you can leverage this. If you're using an older version of Hyper-V, so let's say 2012 R2, 2012, 2008 R2, or something like that, then there is no native change block tracking in Hyper-V. He then decided to say, okay, well, this is a problem that we need to fix. So we created a proprietary change block tracking mechanism, which is essentially a file system filter driver. This file system filter driver is installed on a Hyper-V host when you add it as a managed server, and when you then execute a job with a full backup against this host the first time, this file system filter driver is then activated. So let's say you're using Hyper-V 2016, but your VM version is older than that because you upgraded your host, but you didn't upgrade the VM version. Well, then that's actually a very bad spot to be in, because that means you cannot use resilient change tracking. But you can also not use Veeam's proprietary change block tracking because we didn't install that on 2016 servers. This means that actually Veeam will fail over to what we call our proprietary filtering mechanism. This is also what we use for VMware. If you have a virtual machine that's running older version than hardware version 7, so like that could be version 4, for example. Sometimes customers forget to upgrade the hardware version. When we use the proprietary filtering mechanism, what will happen? Essentially, we'll extract every single block and see, do I already have this block on the backup repository? Yes, just discard it. If we don't have it, then store it. So this is essentially the same as a full backup because we are extracting all of the blocks, but we're actually only storing changes on the repository. But as you can probably imagine, that's going to take a very long time. Just try and imagine a 10 terabyte file server and only 1 gigabyte changed. If you have change block tracking, we can just ask the hypervisor and say, oh yeah, this 1 gigabyte changed. We'll download 1 gigabyte when we're finished. Without this, using proprietary filtering mechanism, we need to download 10 terabytes and then block by block compare. And then finally at the end discover that, oh yeah, only 1 gigabyte was changed. The resulting backup file is going to be exactly the same, but the time we need to come to this result is going to be many, many, many times more than if you had to. What else can we do to optimize data? So we actually have some features here to help you manage large volumes of data, reduce backup storage consumption, reduce the amount of data sent over the network. So let's take a look at those. We have deduplication and compression. If you want to create change to deduplication settings of an existing job, meaning a job that's already run at least once, then you can't just change them, click OK, and then they'll be used. So then you would need to change the settings and then perform an active full, or you would need to perform what's also called compact, which essentially creates a new full backup file. If we're talking about compression settings, you can go in and change the modifier. So anytime the job is not running, you can just go in and change the setting, and then all data files created, all data blocks extracted will have the new compression settings. Any questions so far on this?
For example, if you have a having a is there any way that you can do that from the context?
When you say empty, you mean white space, because the blocks were not used inside the operating system?
That is correct.
Yeah, so as long as you keep our deduplication enabled, it actually eliminates these. So deduplication will eliminate identical blocks or blocks of free space, which of course will decrease the size of the created backup file. So this happens automatically as long as you don't disable the data deduplication. So the example here, you can see we're sort of extracting blocks, and there's some blocks that are there multiple times, but the resulting DDK file is deduplicated these blocks and only saved the unique blocks once. All of this change block tracking is happening, of course, on the hypervisor side, but we're leveraging that information on need to actually extract and then later on send to the backup repository. Another really cool feature that we use to optimize the data size is a feature called bit looker, or zeroing out dirty blocks. So when you have a virtual machine that's running in production, oftentimes what happens is that some data is going to be written, maybe it's some kind of temporary data, and then it's deleted. If this machine is a Windows machine and it's using the NTFS file system, well then essentially what's going to happen is that Eve is going to access the MFT file on the virtual machine SOS to identify which file blocks have been deleted, and then zero out these blocks during the backup. So Eve will then process and transport data blocks to the image in the following manner. So if a data block, the VM image contains only deleted file blocks, then VM does not read this data block from the source data store. If a data block of VM image contains zeroed out blocks and other data, then the backup application copies this block to the target. Due to data compression, data blocks that are marked as deleted and compressed, the size of the resulting backup or replica file reduces. So you can hopefully follow along on here. So on the diagram, you can see all of these gray blocks are blocks of data that have been deleted. So we can read that MST file, identify that, hey, these are blocks that contain deleted data. We don't need to back up those. Eliminate all of those. Take red blocks to be processed, and then only the blue blocks.
Sick.
But why the data for I don't get the product division now.
Okay, so let's try and think of it this way. You have a virtual machine that's running Windows.
Okay.
Then you go in there and you have maybe you're creating some music at home. And you decide, okay, actually I'm going to save my 100 gigabytes of keyboards MP3 files that I created at home on this server here. So now the size of this machine increased by 100 gigabytes. Then later that afternoon you realize, okay, maybe using the server is maybe not the very best place to store these music files. And you decide to delete them again. So right now the size of this virtual machine actually contains 100 gigabytes of data. Because when you create files inside Windows and delete, well then those blocks are marked available and overwritten, and the actual data is not removed from inside the VCA file or the AXDX file. So when V comes along, if this feature is disabled, you actually go ahead and back up 100 gigabytes of MP3 files, even though you deleted them. But if you enable this feature, and by the way, it's enabled by default, then you will realize that you deleted these, and then not include them. Thereby increasing the backup by 100 gigabytes. We touched on data encryption a little bit earlier, so we'll come back to that topic again. So it's probably a good idea to protect information from unauthorized access, especially if you're backing up sensitive data to false applications or archiving tape. Maybe someone else could come into possession of that tape. So to ensure that your data is safe, you could go ahead and use data encryption. Data encryption transforms data to unreadable strangled format with the help of a cryptographic algorithm and a secret key. If encrypted data is intercepted, only the recipient will secret key reverse information back to the reader. Now, the algorithm that we use as always is AES-256, and depending on your CPU, some, especially newer Intel CPUs, have an AES offloading instruction set on the CPU. If you have this, there's still a small overload overhead, maybe 20%. But if you don't have this instruction set, then it could be around 50% of overheads. So that's a lot of extra CPU power that you need. Not only for encrypting it, but also later on, if you need to decrypt it again, using some kind of resource, for example. Now notice here that it says use a password. This is key 1, but there is also this key 2. So there are 2 different keys that can actually decrypt this data. And the second key is this enterprise manager recovery key. So you remember that I mentioned that we have this data loss prevention. So if your lead backup server is added to enterprise manager, the enterprise manager has some certificates. You can control how often those are reviewed and so on. Those latest keys at the point in time of the backup will be used to go ahead and encrypt this. And if you don't have the password, well, then you can use these certificates to decrypt the data instead. We actually have a lab exercise where you need to decrypt a file without the backup and password, and then use it in the certificates instead to go ahead and decrypt it. It's actually really cool the way this works. So let's take a look. If we are looking at source encryption, right? So in this case, we are performing the actual backup right now. So the proxy is pulling data out from VMware or Hyper-V. Then this data mover service that's doing the extraction of data is also the data mover service that will be doing the encryption. If we're talking about in-flight, so you're saying, well, I actually don't want to save my backups in encrypted formats. I just want to make sure that while they're being transferred between 2 data movers, then they should be encrypted. Well, then again, it's still the source data mover service that does this. Then the target will decrypt it before storing it down onto disk or wherever it is that it's being stored. And finally, if we're talking about at-rest encryption, meaning you're sending this backup to tape and want to make sure that it's being encrypted, well then it depends a little bit. So most libraries can support hardware level encryption. If the library supports hardware encryption, then we will just leverage that. So of course, I don't know what kind of encryption that's going to be. You would need to check with the hardware of the library. If the library doesn't support it or it's disabled on the library, then you can still use means software encryption. Now, a tricky thing here is if you have a backup job where you enabled encryption, and you then decide, hey, I want to send this backup to tape, and I want to have it encrypted again, well, then that